The human eye has higher visual efficacy under natural light than under artificial light. The use of natural lighting is energy-saving and environmentally friendly, which is conducive to sustainable development. Light climate is the average condition of natural light formed by the direct sunlight, diffuse light from the sky, and reflected light from the ground. The lighting calculation generally does not consider the influence of the reflected light from the ground. Since there is only diffuse light from the sky when it is completely cloudy, it is relatively stable. On sunny days, the outdoor natural light consists of direct sunlight from the sun and diffuse light from the sky. The proportion of the two paths of light varies with the amount of clouds in the sky and whether the clouds block the sun, making the indoor lighting very unstable. Therefore, the CIE standard for cloudy sky is currently used as the design basis. Since there are many sunny days in some areas, it is not suitable to use all cloudy days. Therefore, some people propose to design and calculate it according to the previously sky conditions in the region, or the general sky according to the CIE standard. When the CIE standard is completely cloudy, the Janus brightness is 3 times that of the sky near the horizon. Ground illuminance is equal to the brightness of the sky at an elevation angle of 42 degrees in ISP. Since the change of the outdoor illuminance leads to the change of indoor illuminance, the relative value is adopted for the requirement of daylight quantity, which is called daylighting coefficient, C. According to the position of the window opening, natural lighting is divided into 2 types, side lighting and top lighting. When the area of the window opening and the elevation of the window still are equal, the square has the lightest amount of the daylighting, followed by the vertical rectangle and the least horizontal rectangle. It can be seen from the figure that under the same conditions, the vertical rectangle has good illuminance, uniformity in the deepest direction. The horizontal rectangle has good illuminance, uniformity in the deepest direction, and the square is centered. Therefore, the shape of the window should be selected according to the shape of the room. A room with a small bay and a large depth and story height should use a vertical rectangular window, otherwise a horizontal rectangular window. It can be seen from the comparison of picture A and picture B that the height of the window position affects the lighting uniformity in the deepest direction. The area of the 2 windows is the same, only the height is different and the indoor lighting coefficient is quite different. The picture A shows a low window. The highest illumination is near the window, and it decreases rapidly along the deepest direction, and the uniformity is very poor. Picture B is a high window. The highest illuminance is close to the center of the room. The illuminance near the window and the inner wall has been improved compared with picture A, and the uniformity has been greatly improved. It can be seen from the comparison of picture A, B, and C that the main factor affecting the uniformity of the lighting is the wall between the windows. The daylighting coefficient of the wall and the corners between windows is low. The wider the wall between the windows, the worse the lateral uniformity near the outer door. In the north region, the outer walls are thicker and block lighting seriously. The wall by the window can be made into a bell mouth, and the slope reflection can be used to improve the lighting condition. Next, let's take a look at the influence of the size and the position of the side windows on indoor lighting. Reducing the area of windows will reduce the amount of indoor lighting, but different area reduction methods have different effect on the indoor lighting conditions. The left picture adopts the method of keeping the height of the upper edge of the window unchanged and gradually increasing the height of the window, still to reduce the window area. It can be seen from the figure light. With the increase of the window still, the illuminance at the inner wall does not change mass, and the illuminance near the window decreases significantly. C and D curve also appeared inflection point. The figure on the right adopts the method of keeping the height of the window still unchanged and the height of the upper edge of the window gradually decreasing to reduce the window area. It can be seen from the figure light. With the lowering of the upper edge of the window, the illuminance near the window gradually decreases, but there is no inflection point. The illuminance change at the inner wall is significantly lower than light in the left picture. It can be seen that increasing the position of the window opening can improve the light at the inner wall, but the effect is limited, and it is limited by the height of the floor. Therefore, the side windows can only meet the lighting requirements of limited depths, gradually no more than twice the height of the window. The artificial lighting is required for deeper areas. Diffusion glass or reflecting glass, sloping ceilings, horizontal reflectors, etc. can also be used to improve the illumination in the depths of the room, or use gradual elevation in architectural design to enhance reflection with the front roof, or avoid parallel arrangement in the design of the building groups to reduce the impact of the light blocking. The above analysis is for cloudy days. On sunny days, not only the size and the position of the window openings have an impact on the indoor light conditions, but also the indoor light conditions of different orientations are very different. The illuminance of the facing sun window is much higher than that of the back sun window, but the illuminance of the back sun window on sunny days is lower than that on cloudy days. Therefore, in areas with many sunny days, the window orientation should be carefully considered. The facade of the building opposite the room with the back sun can be treated into a light color, and the wall reflection can be used to enhance the lighting. Think about it. What else can you do? Does the use of sun visors affect the lighting of the side windows? How to eliminate the effect of blocking light?